Hello! In this lesson, you will be working with the Pythagorean theorem. So what's a theorem? A theorem is something we've observed as a pattern, and we don't know if it's true or not. We just know it seems to work whenever we do it. In math, we haven't really proved it until we can show it's true for any triangle. And the way we do that is, you'll see in the lesson, we use variables for the side lengths, A, B, and C. And we'll be talking a little more about that at other points in this unit and during live lesson. So here you've got a couple of different types of problems, okay? This problem here from your practice, you're actually going to be just using it to find a missing side length. This problem here, it says just give an equation. Okay, so we'll just be kind of getting our heads around when to use it. Here they're going to ask us which is the hypotenuse, okay? And that's an important point. So the Pythagorean theorem is just an equation, okay? Like I said, we have to prove that it's true for every triangle, and it's only true for right-angled triangles. So I'm trying to draw a right-angled triangle here. It's not, the sides are not very straight. But one thing you have to know is that C has to be the longest side, and we call it the hypotenuse. Why do we call it the hypotenuse? It was named, by the Greeks, so it's a Greek word. And then for some reason, A and B, it doesn't matter which one's A and which one's B, because if you look at the equation, we're going to square them, then we're going to add them, and we can add in any order we want. So A could be here, A could be the base, it doesn't matter, but we call these legs. Leg A and leg B. Okay, why do we have this fancy Greek word for hypotenuse, but we just call the other two sides legs? I don't know. All right, so if we have, if we are given the sides of a triangle like here, the hypotenuse is always going to be the longest side. Okay, and it's really important to be able to identify it, because if you look at the equation, C is sort of the odd man out over here. Okay, and if we don't identify it correctly, the math isn't going to math. The equation's not going to work out. Okay? So identifying it is actually really important, okay? And that's why here in this question, use the Pythagorean theorem to give the equation that is true for the given triangle. Do not solve it. We have to identify the hypotenuse because that has to be C squared, okay? It doesn't matter if this is A or this is B. Okay, but the hypotenuse must be C. So here we can say C squared is equal to 9 squared plus 12 squared. Okay, and later on we'll be solving these equations. We'll have to use some square roots. Let's see, I think I'm going to do that here. So this is item 5 of your practice. This guy was item 4. I'm pretty sure this is a quick check. So take a look for that. I don't know which one it is, unfortunately. Okay, so triangle GHI is a right triangle. The length of one leg is 11, and the hypotenuse is 22. What is the length of the other leg? So here's the hypotenuse. Here's one of the legs. I don't know if it's this guy or this guy. Doesn't matter. Okay. But I know that C has to be the 22, and then I can make the 11A or B, and then the other one's going to be my unknown. So if I write this in the Pythagorean theorem, I'm going to say hypotenuse squared, 22 squared, is equal to 11 squared plus x squared, because I don't know the length of that other leg there. 22 squared, I don't know what that is. I'm going to do it in a calculator. 484. Eleven squared, I know, that's 121. Okay. What I'm going to do now is solve. And that means I'm going to get the variable by itself. Let me move me over here. So if I want the variable by itself, I've got to keep the equation balanced. That means I do the same thing on both sides. And I'm going to get rid of everything around the variable. I have to get rid of the 121. Okay, I'm going to subtract it. That'll zero it out. Okay, when we say it cancels, is because 121 minus 121 is 0. But guess what? If I subtract 121 on one side of the equal sign, I've got to do it on the other side too, so that my equation stays balanced. So I get 363. That will equal x squared. Okay? Now, I don't want x squared, I just want x. Okay? So the same way the square root of 3 squared is equal to 3, the square root of x squared is going to equal x. But if I square root on one side, I'm going to square root on the other side too. Okay, people are thinking, wait, what do you mean the square root of 3 squared is equal to 3? Well, think about it. The square root of 9 is equal to 3, right? All right, so now I'm going to go find a calculator and find the square root of 363. Square root of 363. Yikes. Look at this number. Let me see if I can just copy this. This looks irrational to me. Remember we talked about irrational numbers? Okay. Let me zoom in a little bit on this number here. I'd like to move it around if I can. There we go. Let's zoom in and let's talk about rounding. Okay, so when we round, we're going to chop off part of the number, but we're going to leave kind of the ghost of the number that we chopped off. Okay, and they're going to tell us how many decimal places they want us to round to. It's right here, 2 decimal places. Okay, aka round to the nearest hundredth. Okay, the first decimal place we call the tenths place. That's the 0 here. The hundredths place is the 5. So basically, I want to cut the rest of this number off. It's irrational. It's going to go to infinity. I don't have time to write it. But I want to know, I mean, how big was it? Was it so big that we're really close to 0.06? Okay. No, it's pretty small. It's a 2. So the 2 tells us to round down. Let me get another color here, actually. Let's make this a little colorful. So we're going to round down because of the 2. So there's some kind of rhyme about rounding. It says, it's like it's the nosy neighbor. It looks next door. If it's 5 or more, you add 1 to the decimal place you're looking at, the hundredths. If it's less than 5, you let it rest. Okay, so anyway, this here is rounded to the nearest hundredth. I know because the hundredths place, the second decimal, is the last decimal I have. Okay, and it has the ghost of the rest of the number because everybody knows that the part I cut off was less than 5. Okay, well that's that one. I hope this video was helpful. And as always, let me know if you need anything.